We know more about the configuration file. We talked about the storage piece quite a bit, right? We've talked about the storage backend. We understand that it configures the location for the storage of our Vault data, but let's go a bit deeper because none of the objectives for the exam really dive deep into the storage backend. I believe objective 9 maybe mentions it, but I want to make sure you fully understand everything on the storage backend. So again, storage backend, configuration of our storage of Vault data. Open source users can choose a storage backend based upon their preference. And what I mean by that is if you are running in Azure, choose something in Azure. Choose something that you're comfortable with. Don't choose S3 if you're running in Azure if you're not comfortable with configuring S3. Choose something that you're comfortable with and will work for your cluster. Now, remember, we'll talk about this in a minute. Remember that some of the storage backends support HA and some don't. So we'll go through a flow chart on how to select the storage backend that you want to use. Now, Enterprise Vault clusters should use either HashiCorp Console, which for the long time, that was the only option for enterprise clusters, or now with Vault 1.4, you can use integrated storage. Now, integrated storage came out in Vault 1.4. It's been slowly iterating and they've been adding some of the features that were originally in console to integrated storage. And actually, with the release of Vault 1.7, integrated storage is pretty much on par with a lot of the features that you would find in console. So when integrated storage first came out, it did not have cloud auto join. It did not have a agent in order to do automated backups, nor did it support anything like autopilot. So those were features that you get with console. They did not come with integrated storage. But now, since 1.4, and I believe there was something added in 1.5, 1.6, and 1.7, integrated storage again is on par with console, and it should be probably your top choice if you're going to run an enterprise vault cluster these days. Now, everything else beyond console or integrated storage is kind of deemed community supported. It can be used for open source. Again, if you're going to use enterprise vault, you want to use console or integrated storage. Those are really the two that HashiCorp technical support is going to want you to run on. Not to say that they won't help you if you're using some other storage backend, but that's what you want to be running on. All right, so these are the options that we have for storage backends. Now, this is updated based upon 1.7, and we have things like Azure, Console, etcd, Google Cloud Spanner. We can run it in memory, right? And actually, if we run it in dev mode, which we'll talk about later, it actually runs in memory, stores everything in memory. You can use MS SQL, MySQL, Postgres, integrated storage, Raft, S3. There's a ton of different options that you can use for your storage backend. And again, if you are running an open source, choose something that works for you. Don't choose something that's overly complex and something you don't understand. Again, if you're running an AWS, choose S3 or DynamoDB or something like that. Choose something that works for you. All right, so let's look to see how this works, right? How does the storage backend actually function with Vault? So we have a Vault node. We deployed a single Vault node. And what we're going to do is we're going to configure our storage backend. And this is where that one node will store everything on our storage backend. Now, when we deploy a Vault cluster that has more than one Vault node, those same Vault nodes are going to interact with that same storage backend. So all three nodes will still consume that one storage backend. So we don't have a storage backend for each node. We have a storage backend for each cluster. Now, this is defined as a single Vault cluster, right? We have multiple Vault nodes. These multiple Vault nodes work together for high availability. You only have one active node at one time. The others are deemed as standbys. Now, this again is cluster number one. If you decide that, hey, I need replication or I need redundancy in my environment, and I'm going to stand up another cluster somewhere else. You're going to stand that up in another data center, another cloud, wherever else, but you're going to have other nodes out there, whether they're running in containers or VMs or instances or whatever. But note that that other cluster is going to have its own storage backend. It doesn't share a storage backend with the one over here on the left. It has its own storage backend. Now, again, if you decide to expand that one out and make it a cluster, the same thing is going to happen. You have all the nodes within a cluster are going to share that storage backend. So again, this is Vault Cluster number 2. Now, if you happen to be running Enterprise, and we'll talk about replication in this course, but if you are running Enterprise, this is where replication happens. It doesn't happen between the storage backends or anything like that. It happens using APIs between the Vault nodes themselves. So the cluster over here in the green, it never actually talks directly with the storage backend over here in orange. And vice versa, the cluster in blue never ever talks directly to the storage backend over here in the green. The nodes talk among themselves, and that's how you get replication configured. The other thing I wanted to point out here is that on the left, you can have different storage backends on your cluster. So you can see over here on the left, maybe this one is running console, and the one on the right is running Raft. So you can have different storage backends on your Vault clusters just depending on your needs. So again, really the purpose here that I wanted to just showcase is that there's only one storage backend per Vault cluster. So every time you stamp out a new cluster, you're going to create a storage backend for it. All right, so let's talk about how do we choose a storage backend? And the first thing we have to decide is like, is this going to be for production? If it's not going to be production, then hey, let's just run it in memory. Who cares if we lose data? Maybe it's for a test or something like that. So just use in memory. And to do that, you can just run Vault in what's called dev mode. If it is in production, the other question that we have to ask ourselves is like, hey, do we need high availability? If we don't need high availability, then we can say, do we need HashiCorp supported? And we could say, if we don't, then we can choose these options here. If we do need HashiCorp support, then we choose the file system. Now, if we do need HA support, which I would guess most of you are going to, right? We kind of follow over here and we say, oh, by the way, do we also need HashiCorp support? Like, are we running Enterprise? If we're not running Enterprise, we've got these examples. So these examples like DynamoDB, etcd, all these kind of things, these support HA, but they're not supported directly by HashiCorp technical support. So if you do need technical support, if you're running on Enterprise, then you would choose either console or Raft. Hopefully this kind of gives you a good breakdown of how to choose a storage backend. Now, if you get into these larger groups where there's a bunch of different options down here, again, choose the option you're most comfortable with, or choose the one that has the best tool set for backups and stuff like that. All right, so how do we configure our storage backend? We saw earlier back in our configuration file that we configure it in the storage stanza in our configuration file. So the two examples here I have is console and integrated storage. Again, these are probably the two most popular ones. So for console, we define it as console up here. The address is 127.0.1/8500 because if we are using console as a storage backend, each individual Vault node will also run the console agent in client mode. So Vault will just talk locally to the local console agent, and that will relay any information to the console cluster or retrieve any information from the console cluster. Now the path here is defined as the path on the backend KV of console, right? So what path do we want to store all of our data? Most of the time I just use Vault. That seems to be the default. And of course, this is defining a token as well. So if you're using console, you want to make sure you have console ACLs enabled for security purposes. And if you do, that means this agent and Vault also need a token in order to successfully talk to console. So again, type of storage backend is console here, the IP or port of console agent. The path in console KV to store the Vault data is here. And then of course we have the console ACL token. All right, so at the bottom here, let's talk about integrated storage. So we have the same stuff, right? We've got the type of storage backend and we're declaring it as Raft. Raft is the actual protocol that integrated storage uses. By the way, Raft is also the protocol that console uses as well. And HashiCorp kind of ported over the Raft protocol into integrated storage. So again, Raft is this type of storage. Now this piece here is the local path to storage replicated data, meaning on the Vault node itself, where are we going to store data? And this is where. So in this case, we're saying, hey, Vault node, store all the replicated data in opt Vault data. Now we have the name or the ID of each individual Vault node, and that should be different on each Vault node. And finally, we have different cluster join options. In this case, I'm using auto join or cloud auto join. So we have the Vault node when it comes up, it will go look at AWS EC2 tags and it'll find ones that have this specific tag and then it'll try to automatically join the cluster. There are other ways you can do it. You can do it manually. You can put the IP addresses or host names in there. But in this example, I'm using Cloud Auto Join. So hopefully this kind of breaks it down for you a little bit and you understand how to configure a storage backend. Remember, if you're using some of the other options, jump into the HashiCorp documentation. They have it all listed out nice and easy for you. All right, almost done with this section. We've got a couple more things that I want to talk about here. One is the audit device. This is one of the core components of our Vault clusters. And an audit device, again, is exactly what it sounds like. Keeps a detailed log of all of our authenticated requests and responses to Vault. So if you look in an audit device, if I log in, if I go and grab data from Vault after logging in, you will see both the request that I made and then you'll see the response that Vault sent back. Now, all this log data, again, is formatted in JSON, so super easy to parse. You can obviously send all this data, and you should send all this data up to a SIEM or some log aggregation tool so you can alert on different things. Again, sensitive information is hashed, so we talked about that earlier. Log file should be protected as a user with permissions. They can still check the value of those hashes using the STS audit hash API and compare it to the log file. So even if those sensitive values are hashed, right, you still want to protect this log file. All right, so how do you enable an audit device? So on the CLI, you can do something like Vault Audit Enable, and then you have file, which file is the type of audit device that we're going to use. And then file path is one of the configuration files for the file audit device. So we're going to say, hey, I'm going to enable a file audit device, meaning I want to store all my logs in a local file. And the file path of where you want to store it is var log vault audit log.log, whatever you want to call it. I just called it that, but you can call it whatever you want. The one thing to note here is you also want to make sure that the user that you're running Vault as, when you launch Vault on your nodes, you want to make sure that the user that's running that service, a lot of times I just call it Vault, try to create a new user, and Vault runs as a user called Vault. Make sure that that user has access to write to this path. Otherwise, if it doesn't, Vault will yell at you and you'll get an error saying, you don't have access to write to this path. So you have to go fix that permission and then rerun the command. All right, so let's talk about the three different audit device types here. So we have file, which again is super simple. It writes to a file, right? Appends logs to that file. Now, Vault does not assist with log rotation, right? It's just going to continue writing to the end of that file. So what you want to do is use something like FluentD, CloudWatch Logs Agent, some other tool, whether it's Splunk or Logarithm or any of these other options. Use a similar tool to send these logs to a collector and then make sure that agent is also handling log rotation for you. I sent all these logs up to my SIEM or my log aggregator. Now I can successfully delete them without fear of losing any of my logs. The other one is syslog. So it writes audit logs to an upstream syslog server. So what happens is usually you run like a syslog agent locally and you send that local agent the logs and then that local agent will send those upstream for you. Now the last one is socket here. So writes to a TCP, UDP, or a Unix socket here. HashiCorp says it's unreliable, and that's really due to the underlying protocol of UDP. So if you need like strong guarantees for your logs, definitely don't use UDP. Hopefully you understand that UDP kind of just blasts it out and it doesn't care if you got it or not. Yeah, that's if you want to use socket, make sure you're not using UDP here. All right, so some more information about audit devices. You can and you should have more than one audit device enabled. Again, we talked about this earlier, but if there are any audit devices enabled, meaning I've enabled at least one, Vault requires it can write to the log before completing the client request. Again, prioritizes safety over availability. Now, if Vault cannot write to a persistent log, it will stop responding to client requests, which essentially means Vault is down. If I'm not responding to clients, Vault is down to clients. So make sure that if you're enabling audit devices, which you absolutely should, but you're taking care of those logs and you're at least enabling more than one audit device. All right, last piece here. Again, Vault requires at least one audit device to write the log to before completing the request if you have it enabled. So again, very important point to keep in mind. All right, so the last topic that I wanted to touch on before we jump into Vault installation is talking about the Vault interfaces. Now, I've already mentioned Vault interfaces a few times throughout this introduction, but I wanted to officially introduce them to you as the student. So Vault has three different interfaces that we can interact with when we're interacting with Vault. So that's the user interface, the command line interface, and of course the API. Now, not all of the Vault features are available in the UI. So the UI is still kind of a work in progress, I would say. They're constantly adding new features to the user interface, but there's still a lot of things that you can't do in the UI. So just be aware of that. Same thing goes for the CLI, although I think you can pretty much do everything in the CLI now. There are very, very few things that I have found that you cannot do in the CLI. However, with that said, all of the features can absolutely be accessed using the API. So for example, anytime HashiCorp is going to introduce a new feature to Vault, it's always going to have a related API. Now, sometimes it'll also come with the CLI and sometimes it'll work with the UI, but it's always going to work directly with the API. Now, when you are working with the UI or the CLI, any calls that you make or any configurations that you make in either one of those interfaces, they actually invoke the API. So if you think about being on the CLI and writing Vault commands, the CLI is actually just kind of a thin wrapper on the API itself. All right, so when you start a Vault server, you're always going to have the CLI available. You're always going to have the API available. However, by default, the UI is not enabled. So you must specifically enable it in the configuration file. And we saw that earlier when we were talking through the configuration file where it had UI equals true. So if you want to use the user interface, make sure you have that in your config file. And lastly, it doesn't matter which interface that you're going to use in Vault, you must authenticate before you can send any other commands to Vault. So if you are going to use the CLI, you must use something like Vault login and then log in somehow, and then you can run commands to grab passwords, generate database credentials, encrypt some data, those kind of things. You have to authenticate first before you can do anything else. And again, we'll get into a lot of these down the road. So let's introduce Vault interfaces again, but we'll talk about how they relate in regards to the different users that are going to interact with Vault. So again, we have our Vault interfaces, we have our user interface, we have our command line, right, our CLI, and then we have our traditional API. Then we have different users who are going to interact with Vault. Now, these may be humans or users. It could be you as a student, taking this course. It could be a developer. It could be, colleagues, whatever. But in this case, we're thinking about a human user. Maybe we have some orchestration tools, something like Jenkins, Circle CI, Chef, Puppet, any of those kind of tools that are helping orchestrate the implementation and the provisioning of applications in our environment. They may also need to interact with Vault. And finally, we may have applications that have been written to interact directly with Vault itself. So let's talk about how these different interfaces are used by these different users. So humans, of course, they can use the user interface. That's exactly what the user interface is designed for, human interaction. But humans may also use the command line as well. So if you pop in the Vault binary on your local machine and you set the Vault ADDR environment variable to point to your Vault cluster, you can easily interact with Vault on your local machine. Now, when we're talking about orchestration platforms could use the command line. Not necessarily they have to. They can also use the API if they like. But orchestration tools are going to probably interact with Vault using a command line interface or the API interface. Honestly, it's probably going to be most of the time the API side, but you may have like a Jenkins where you're just doing like a CLI commands or something like that instead of using the API or like a Jenkins plugin or something like that. Now, finally, when you have applications interacting directly with Vault, they of course are going to almost exclusively use the API. Right? So these applications are going to go to Vault, they're going to authenticate, they're going to get a token from Vault, and then the applications are going to use that token to interact with Vault. Go retrieve secrets, go generate credentials. Now, these applications, when they are rewritten to take advantage of the Vault API, they must also be aware of things like the token TTL for authentication, any leases that are attached to dynamic credentials, all those types of things that the application must be aware of when it's interacting with Vault directly. All right, so we're not going to go super deep into each command line and how to use them in demos and things like that in this particular section because the Vault Associate exam actually has specific objectives specifically for each one of these interfaces. And so we will go super deep into each one of these in these sections. So command line is objective 6, utilize the Vault CLI. User interface is going to be objective 7, utilize the Vault UI. And objective 8 is be aware of the Vault API.